So, double angle identities. There's a formula for the double angle identity for sine. By that I mean, the double angle looks like this, sine of 2 theta, or 2 whatever variable you want to use. And so that'd be the same as doing sine of theta plus theta. And that's one of those ones we just learned on the last section. The trig and sum differences. The formula for 2 added together, which again, I'll give you these on the test. You don't have to memorize them. Sine of A times the cosine of B plus the cosine of A times the sine of B. So here's A and B. It's just saying, hey, if those two are the same, then it's sine of theta. I'm just plugging it into this. Times the cosine of theta plus cosine of theta times the sine of theta. Notice those two are exactly the same. They're just in different orders. So I add 2 of those together. That's a total of 2 sine cosine. So that's another trig identity that I will give you on the test that you can use. Double angle identities for cosine. So if I have the cosine of 2 theta, that's the same as doing the cosine of theta plus theta. And we have a nice little formula for that. Cosine of A plus B is the cosine of the first one times cosine of the second one minus sine of the first one times sine of the second one. I'm going to use that green one to do this one. Again, those will all be given to you. We're just figuring them out. So this is A and B. Plug them in there. So that's cosine of theta times the cosine of theta minus sine of theta times sine of theta. So that becomes cosine squared theta minus sine squared of theta. People always want to put 1 in there. That's only if those two are added together. That's a double angle identity for cosine. We can replace cosine of theta with 1 minus sine squared of theta. So another one that we can use for cosine of 2 theta is 1 minus sine squared of theta. Oops, 1 minus 2 sine squared of theta. Or 2 cosine squared of theta minus 1. All of those are different identities that do the same thing. It's just different ones are useful for different things. Again, these will all be given to you. double angle identity for tangents. So if we have the tangent of 2 theta, it's the same as doing tangent of theta plus theta. We have this rule on the last set. That orange one. So that's A plus B. Tangent theta plus tangent of theta. 1 minus tangent of theta times the tangent of theta. That becomes 2 times the tangent of theta over 1 minus tangent squared of theta. So again, that's another one that will be given to you. So this one, it gives you sine and tangent. Well, tells you that tangent is positive. We want to figure out which quadrant it's in. So remember, it's all students take calculus. Sine is negative. Tangent is positive. So which quadrant should it be?
4.
Okay. So is tangent positive in 4?
Oh no.
Yeah.
3.
3. Sine is supposed to be negative, so that means that gets rid of the first 2 quadrants. And tangent is positive, so that gets rid of the 4th quadrant. That's why it's tangent of 3. Draw the angle and label the reference triangle. Okay, so it's in the 3rd quadrant. Here's my angle, called theta. Sine is negative 3/5. Let me label these sides. Which one is the 3?
B.
B, the opposite. And since it's going down, I went ahead and called it negative 3. Which one is the 5? Yeah, it's opposite over hypotenuse, and the hypotenuse is across from the right angle, so it should be C. So does that make it A?
4.
Yeah. And is it positive or negative?
Negative.
Negative because it's going to the left. And then it says order the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta from least to greatest. So that means we got to find all of them. And we use the formulas that we just figured out on the side before. Sine of 2 theta was 2 sine of theta cosine of theta. Now, using that triangle, or the information that we got above it, what's the sine of theta? Yeah. That was given to us. Or if you just used SOHCAHTOA, it's opposite over hypotenuse.